Hi, good morning. I am Nanda Kumar. I am a SolidWorks instructor. Welcome to the program on SolidWorks e-learning. SolidWorks is a 3D mechanical software which is capable of doing sketching, modeling, validation, simulation, product documentation, and product data management. SolidWorks is a user-friendly software which is used by most of the design professionals in large scale, medium scale, and small scale. Since it is an intuitive software, it is most preferred in most of the companies, especially in small and medium scale enterprise. And this software can be learned by any design professional who is interested to learn 3D mechanical software. In this training, we are going to see a brief intro about product development cycle and then different software trained in CAD Center for different applications. And also we are going to see a small intro about SolidWorks and its features. To start with, I would like to give you an overview on the product development cycle. In this product development cycle, you can notice there are 7 stages involved in every product development. For any product in the market, definitely there must be a need. Because of the need, we will start to create, and that's what we called as conceptualization. And before we go into conceptualization, the first process is we need to have a small meeting where engineers, sales, marketing, and all the people will sit together for a debate, and they will come to a conclusion that the product should have these features, it should have these functionalities, and this is used in this environment. And based on this, you will have a small conceptualization, that is, it may be in a hand-drawn 2D sketch, or it may be in a 3D view, or it may be a small prototype of the entire product or a partial of it. Once this is completed, they will go for the next process, that is design. And here, using mechanical application software, they will do the product design and also they will do assembly. And once this is completed, and the next stage is you have to validate. It means we have to give them assurance that this product can work in hottest place and also in coolest place. An engineer who is involved, or an engineer, or I can say a person who is involved in designing a CPU, he must give an assurance that this CPU can work in hottest climate and also in the coolest climate. And this is what every engineer has to give an assurance, and that is what we are doing here, that is, we are validating the product. And once this validation is completed, the next stage is we want to give them the details of the product in production documentation. That is, we want to give in orthographic views, sectional views, and also 3D sectional views. And once this has been completed, now using this, the laborer or the worker or the employee will develop a program, and based on the program, you will go and produce the product. And nowadays, this process is also involved using software. And once the software is used for manufacturing, definitely you can reduce the time involved by reducing the unwanted travel of tool, and you can avoid the cost by reducing the accidents, and also you can use optimization process, which can tremendously reduce the work or the time used to create the entire program for machining the product. Now The next stage is visualization. Once you completed the product using a manufacturing software, the next stage is you would like to show your product in more realistic so that the customer will attract in the first sight itself. And this is what the entire product development cycle involved in any company, and they will do all this using different softwares to develop the product. But when you learn SolidWorks, you can do all this in one single platform. SolidWorks has an interface where you can do sketching, modeling, validation, simulation, as I told previously, and also you can do the product data management, that is collaborating with different engineers working in a small work group. And that's all about product development cycle. And now let us know a small view on the different software trained in CAD Center for different type of areas. Definitely every engineer will be eager to know about this process, that is the different software used for different type of application which is specialized in those areas. As I said previously, SolidWorks is capable of doing all this process, but still there are some software which is most capable of doing those kind of operations. The first process, as you know, conceptualization, and once it is completed we go for sketching, that is 2D sketching. For 2D sketching, the most popular software used in most of the companies, AutoCAD. And for computer aided designing, we use, or everyone has to use, SolidWorks, ProEngineer, NXCAD and CATIA. Now there is a question, why we need to learn multiple modeling software for designing a product? It is very simple. As I said, SolidWorks is most capable for small and medium scale enterprises. When you think about you want to enter into large scale or any type of industries, or it may be you want to design any product range starting from large scale, small scale, medium scale, definitely you should know different platforms. And that's why you have to learn SolidWorks, ProEngineer, NXCAD and CATIA. And computer aided engineering, where we will be doing the validation. That is, we are going to apply boundary condition and we are going to find out the stress distribution or pressure, or it may be deformation of any product. Here we use Ansys, Nastran and Pro Mechanism. And last, with manufacturing, we use NXCAM and Pro Mold, which is entirely giving solution for tool design and also for machining. And that's all about product development cycle. To make it one more time to make it more clear about what we discussed previously, we started with the product development cycle, and we had seen a small intro about the different software used in different areas, and now we are going to start with features of SolidWorks. As I said, SolidWorks is used in most of the industries. Now definitely everyone will be interested to know about the features in SolidWorks. The first one is feature-based modeling, which is common in most of the modeling application. What do you mean by feature-based modeling? Feature-based modeling is, now you just look into these images, process 1, process 2 and process 3. What we're doing here, we are going to create a block with a hole, and also the 4 corners has to be blended. And if you want to create these type of model, the first process involved is creating a block, and we are blending all the sharp corners. And third process, we are going to make a hole, and this is called as feature-based modeling. Feature is nothing but a building block in a geometry, and as you know, geometry is a easily understandable shapes, and This is known as feature-based modeling. The next feature is parametric design, which is the most requirement for every mechanical engineer who works in a company. And here, what is the meaning for parametric? Parametric is nothing but a model driven by variable dimensions. Here we have an initial model. This is a cylinder head, which is used in engine. And here the first image, you can see the initial model. You can see there are 4 holes. Now I would like to increase the length of the cylinder head. Now when I increase the cylinder of the head, or when I reduce the diameter of the hole, you can see the other design intent is not disturbed. And you can see in the third image where you can see the hole size, once again it is reduced, and there also you can see there is no design change in the other geometry, only the hole has been changed. And this is what we call as parametric design. It means the whole geometry where you can see number of features, every feature will be parametrically related. And if you change any one feature, only that feature will be changed, other design intent will not be disturbed. The next feature is bidirectional associative, which is more interesting in SolidWorks. You do part and you do modeling, and once you complete the assembly modeling, you will go for creating the production document drawings. And what you see here is exactly the product, that is the production document drawing. The first image will show you the part created, and the second image will show you the part is used for creating orthographic views. Now the situation is the engineer will create the first connecting rod and he will go and create orthographic views. So these are 2 different separate files. Once he designed and he goes for creating orthographic views, now there is a small feedback from the assembly department says that all the sharp corners has to be blended to avoid the sharp corners, so that it will not damage the users. So if he had this feedback, and now if you want to modify the sharp edges, he will blend it using a command called as round. If we apply the round immediately, that will be reflected in the drawing also. This is what we call as bidirectional. And if you reduce the hole size, it will also reflect in the associative drawings. And moreover, if he changes anything in the drawing environment, that is in orthographic views, it will reflect in the part and assembly. This is what we call as bidirectional associative. And now these 3 features is common in almost all the modeling software. Now I would like to show you the unique features, or I can say these are the salient features in SolidWorks. The first one is graphical user interface. Graphical user interface, you may be surprised what is about it. Every user will be having a small knowledge on MS products, such as Microsoft Office products. SolidWorks is also having the similar environment of MS products. So the user who want to learn the software can easily adapt to this graphical user interface. And the next one is easy migration from 2D to 3D. So what is about it? Now a company is using a 2D software for a number of years, and now they want to shift from 2D to 3D. What they will do it? They will look to a software where I can understand my conversion of 2D to 3D as simple as possible. Here SolidWorks, which is capable of doing this process so simple. How? Definitely we will see in the later session. And the next, process specific features. There are 2 components. One is phone and one more is calculator. And if you look into these products, there are some specific features where you will be using frequently. Example, there is a hole we called as vent hole, and there is a one more mounting used for assembling two components. And here you can see the shape will be having a lip. There will be an option of using a provision to assemble two components. To create these type of plastic components, we require some specific features where you don't want to create it. You can just call the feature, you can place it there. This is what we call as process specific features. The next one is SolidWorks Task Scheduler. The biggest advantage with the SolidWorks Task Scheduler is, now there is a situation. You have a task of updating all the part files which is done in SolidWorks 2008, and you want to convert these 2008 files into 2010 files. Now the typical situation, what you will do is you will open the files one by one and you will convert or you will save it. But using SolidWorks Task Scheduler, you can do it as simple as possible. So what you'll do here, we used to open a separate task scheduler application which comes with SolidWorks, and you will show the path where this file has to be converted. So this will be converted into the new version which you want to do it. So this, you don't want to require the manual input. You can give a schedule time, starts with 9 o'clock, end with 5 p.m. And also you can do some of the process like printing the documents and creating drawings automatically by using templates, etc. You can do all this using SolidWorks Task Scheduler. Now next, toolbox. SolidWorks Toolbox will give you standard nuts, bolts, washers, spring, and then split pin, and apart from that you have power transmission. That is, you can also get spur gear, helical gear, bevel gear, rack and pinion. All this will be available in SolidWorks as a library. You can retrieve and you can use it wherever required, where you can save a lot of time involved in creating this standard components. The next one more thing is advanced commands. When you look this product, I hope you know this is a speaker, and this speaker, you can see it looks so stylish, where you can see the features are blended and it is twisted, it is rotated. And now if you want to create these type of features, definitely you have to create the product using advanced commands, where SolidWorks will use commands like freeform, where you'll be able to drag the surface and you will create an like a clay modeling, and you can also twist, blend, whatever you do, you can do it here using advanced command. And next, one more thing interesting, PDM, that is product data management. As we know, the world everywhere we are involved in globalization, and every company is required to do this process, and that's why PDM is more important, because we should know how to manage the different data available with the different peoples, and that has to be collaborated. And that's entirely what we are doing. We are going to see in product data management. You will have a centralized vault, that is, we will use a server machine, and these different processes are done in different locations, and these different locations will be accessed through the server, and all will be collaborated together to complete the project. And the next, I will go into Weldment. This PDM will be a separate module, which is an application which runs inside SolidWorks, or which can run as a standalone application. Definitely we will see this PDM in detail in later session. And next, one more thing, Weldment. An image which shows an automatic robotic system, where you can see number of structural members. As of now, we had seen only single product design, but once you complete single product, definitely you need to assemble all this product in an entire structural member. That is, you have to do it in a framework. This structural design fabrication assemblies, definitely you can do it using SolidWorks in a user-friendly way. If you look into these type of assemblies, the first primary requirement is we need the information about the cut list. That is, when I create the whole design, how many structural members I will use here, what is the length for the individual members, and all this you can achieve as simple as possible in SolidWorks. And with this, I would like to end up with the various products available in SolidWorks for design, managing, that is management, analysis, sustainable design, communication, free CAD tools, and free 2D and viewer tools. I'll give you a small view on this. Design, that is for creating 3D models, managing the product data management, analysis where you will do validation and also simulation, sustainable design, which is specifically focusing on a design where you will reduce the usage of material, thereby reducing the carbon footprints, which is most necessary for every engineer to know before they produce any product. Communicate, it is without the SolidWorks software, you can communicate your ideas using 3D via Composer, where you can show them more realistic in nature. Free CAD tools, which makes the engineers, the students who want to design their products can download all this application which is available in SolidWorks website for creating, for sharing, for editing the designs. And the next one is free 2D and viewer tools. This is especially when the customer is not having the software, they can download the software which is free of cost and is used for just viewing the components or viewing the assembly or viewing the product documentation using eDrawing viewer or using 3D via Composer. And that's all about SolidWorks features. And now let us look into SolidWorks graphical user interface.